My name is Steve Alton. I'm a New York Times bestselling author of fictional thrillers. Unlike my novels, the information you're about to see about a new cancer treatment is factual, it's happening now, and it could save the life of you or a loved one. Chances are you know someone who's been diagnosed with cancer. In December of 2010, my father was diagnosed with lung cancer and liver cancer. He had never smoked a day in his life. Everything stemmed from a melanoma that was removed from his face 3 years earlier. My mother and I were with him the day he was diagnosed, and we were with him 6 weeks later in the hospital the day he passed away. Cancer is a horrible disease, and it tortures its victim, and for a saint like my father, it was torture to watch him die. The real tragedy here is that my father was 2 weeks away from a new protocol that would have saved his life. Watch closely. What you are seeing is time-lapse footage of white cells called CK8 granulocytes that are actually seeking out and attacking cancer cells. These naturally occurring cancer-killing agents target metastatic tumors associated with breast cancer, liver cancer, stomach and lung cancer, as well as other tumorous cancers, including the melanoma that ended my father's life. This exciting new white cell infusion therapy is now being tested for the first time on humans at a private research institute in Boynton Beach, Florida. This is Dr. Ditnarayan Maharaj, founder and director of the South Florida Bone Marrow and Stem Cell Transplant Institute. I've known Dr. Maharaj since June of 2010 when he successfully treated me with stem cell protocol that used my own stem cells to drastically reduce my symptoms of Parkinson's. Unfortunately, my father died 2 weeks before he was supposed to start your white cell infusion protocol. And we're here today to talk about that white cell infusion protocol because it looks like it is the cure for cancer and it needs to be funded. First of all, briefly, could you just explain your background in treating cancer patients?
Yes, Steve. I was trained in Scotland as a hematologist oncologist and specializing in stem cell transplant. And I've been treating cancer for patients for over 20 years.
Could you briefly explain what your protocol is and why it's so important to the immune system?
Yes, yeah. Well, Steve, when cancer arises, it occurs because the immune system has not been able to contain it, and the immune system has become defective or broken down. And so when we give chemotherapy, the idea here is to shrink the cancer. And many times the patients will go into remission, but then we find that the disease recurs. And the reason for that is because with cancer, there are two types of cells. There's the cells which are dividing and the cells which remain dormant. And when the chemotherapy is given and those cells which are divided are killed off, we say that that's remission. But the dormant cells can recur, can begin dividing later when the immune system again is not controlling it.
So for instance, my wife's best friend died of breast cancer. She had beaten it the first 2 times, but it kept coming back. It kept coming back because her immune system was weak?
Yes, it kept coming back because although the chemotherapy that she was given each time would shrink the cancer, her immune system wasn't strong enough to prevent the cancer from not coming back and for her being cured of the cancer.
So I know your white cell infusion protocol, having researched it, was based on a study coming out of Wake Forest University. Could you briefly explain how the white cell infusion works and why it's different from chemotherapy?
Yes. Well, the immune system is made up of 2 parts, what we call the innate and the adaptive immune system. The innate immune system which basically is the cancer surveillance system predominantly. And so when cancer cells arise on a day-to-day basis in everyone, it's that innate immune system which actually will prevent those cancerous cells from becoming a full-blown cancer. What we're doing is taking the innate immune system, which is the white blood cells from young, healthy donors, and giving it back to patients whose immune system is broken down to repair or supercharge their immune system. And in this way, the idea is to kill the cancer cells and then rebuild the immune system so the cancer doesn't come back.
In my dad's case, he had a melanoma removed from his cheek 3 years earlier. They believed that they got it all, but you're saying that the twin that was lying dormant when his immune system went down, that's what caused it to blossom and start spreading?
Yes. What was basically controlling his disease is after he had the initial treatment which shrank the disease, remember the dormant cancer cells which were not killed by the chemotherapy or radiation therapy was actually sitting there it didn't grow because the immune system was controlling it. Something occurred which caused his immune system, and perhaps the stress that he was under, caused his immune system to go down. And that's when the cancer cells, they started dividing, and then they spread because the immune system couldn't control it.
And your white cell infusion therapy is effective not only for melanoma, but other tumorous cancers. What other type of cancers are tumorous based?
Basically, our white cell infusion protocol is available to any patient who has any type of cancer, which is what we call a solid tumor. So patients who have blood cancers, which is really a cancer of the bone marrow, they are currently not eligible to come onto this clinical trial. But breast cancer, lung cancer, colon cancer, prostate cancer, any type of solid tumor, any of the common cancers, stomach cancer, these are ovarian cancers. These are all cancers which can be treated on this protocol. My protocol is based upon the 1999 work, which was originally started by Dr. Cooey at Wake Forest University, where he discovered a cancer-resistant mouse. No matter how Dr. Cooey attempted to infect this mouse with cancer, he couldn't do it. The mouse's immune system was just too strong. What I'm doing, Steve, is translating the basis of Dr. Cooey's work into a clinical trial in humans. Instead of the mouse's white cells, I'm using the white cells taken from the immune system of 20-year-olds. If you take a 20-year-old and you look at the incidence of cancer versus a 70-year-old, a 70-year-old has a 100 times greater risk of cancer. That's because the immune system of a 20-year-old is so much stronger. When the melanoma was removed from your father's cheek 3 years ago, those cancer stem cells were still there, lying dormant. When your father's immune system weakened, those cancer cells flared up. Again, the approach here is to reverse that process by rebuilding or supercharging the patient's immune system using donor-matched white cells from young, healthy 20-year-olds.
This is Claudia Lingieri, the research coordinator at the Florida Stem Cell and Bone Marrow Transplant Institute. Claudia is in charge of the donor program that's so important for the white cell infusion program. Claudia, where do you get your donors from, and how are they screened and matched to the particular patient?
Well, the first thing we do is we focus in on the younger patients, the younger donors who are between the ages of 18 and 25 years old, because their immune systems are the strongest. We get informed consent to make sure they understand what's involved with the study. And then each volunteer will give some blood so we can check for their blood type, their HLA tissue type. We also check to make sure they don't have any infectious diseases that can be sent to the patient. And then we also make sure they're healthy enough by giving them a physical exam. And once we have all that information, they're part of our donor registry. And then we can call on them anytime a cancer patient comes along who has their blood type. When a patient is ready to begin the treatment, granulocytes from several matched donors in our donor registry would be mobilized. We use 2 FDA-approved medications and administer them to the donor the day prior to the white cell collection. These medications safely release high amounts of white cells from the donor's bone marrow into their bloodstream. The next day, the actual day of the infusion procedure, the donor will be hooked up to a machine to collect these excess white cells through a well-established medical procedure called apheresis. An apheresis machine separates the donor's granulocytes from the other blood products that are immediately returned to the donor so that the health impact on the granulocyte donation is much smaller than that of a typical blood donation. Granulocyte mobilization and collection by apheresis have been used in clinical practices for a long time with a very good safety record.
So essentially you're sitting on the cure for cancer for these type of tumorous cancers. I think everyone wants to know what's the holdup, when can we get these cures at our own doctor's offices so that we don't have to go through chemotherapy or like my father did, die from these terrible diseases.
Well, what's holding us up right now is that we don't have funding for this clinical trial, and it is an approved clinical trial, and the first phase of the study calls for 29 patients to be treated, but we don't have the funding to treat those 29 patients. There are many patients who have cancers who would be eligible for the clinical trial, but we're not able to treat them because we just don't have the funding to treat them.
And how much would it cost to complete the clinical trials for these 29 patients to prove your protocol works?
We need $10 million.
And $10 million covers 29 patients, and
Yes, it covers the phase 1 clinical trial that's currently open.
You know what $10 million is? $10 million is 1 million people like yourself pledging $10 to cure cancer. Please go to the website listed below, make your pledge, and spread this link to everybody on your email list. Together, we can cure cancer. Thank you.